Good evening, guys. We are solving the problem remove the every kth node. So in today's problem, we are going to see that it's the third problem of linked list of the Geek for Geek series of this week. And what is clearly understood from this problem statement is that we will be given a linked list of a size n, and then the user will also give the value k. And now we have to update the linked list and remove the values of the kth position and then print the linked list. So I have written the algorithm over here. So if you try to understand this, see for example 1, 2, 3, 4, 5, 6, 7 and 8, these are the linked list items, and the k or k is user defined. So when k is user defined, the output is 1, 3, 5 and 7. So basically when k is 2 means it is skipping one element like every second element. Say for example it is skipping 2 and it is printing 3. After 3 it is skipping again two elements, and then it is printing the 5, and then it is skipping the two elements, and then it's printing the 7. So like that. So if you see the explanation as well, so after removing every second node of the linked list, the resultant linked list will be 1, 3, 5 and 7. For example, you take a linked list of 10 items and k is 3. So if you see, they will remove the third element after every third element. So say for example, they are removing 6, they are removing 8 and like that. One thing you will observe that it is although written 2, but why is it not removing two elements and it is just skipping one element? If you carefully see, after 1, 2 and 3, when 2 is there, so it's skipping 2, but after 3 is being removed, what you can see is what you can see is 4 is removed. So basically linked list, whenever you work with linked list, the easy method or the short trick is to think whatever the array looks like, you have to take array minus 1. So it's like k minus 1, so you will skip one element like that. So it's like 1, 3, 4 is skipping, again 5, one element is skipping, and 7, but it actually means you are skipping two elements if you carefully observe, because when k is equals to 3, you can see the the fourth element or the 4 value is being deleted, and like the third value is deleted like that. Okay, so let's solve today's problem. So basically what we can see is we have to go through the algorithm, right? So what I'm going to try is I'm going to put the algorithm on this side and try to analyze the code. Okay, so first what I have to do is first I have to define a function node delete. So the node function is being already defined, so this function is to delete the particular node, to delete the particular node at the current position. Okay, and when you are coding over here, what you can see is first it is saying the first step is to input head of the linked list and the value of k. Yes, we have taken in the parameter. The output is like the head of the modified linked list after removing the kth node. So what I can say right over here is return head. This will be the return statement. Next, check if head is null or k is less than equals to 1. Yeah, so base cases. So what I can do is whenever you're doing competitive programming, you have to take base cases. So base cases are cases which check whether the particular, whenever the particular code is working, like whether the linked list is empty or the linked list is having no element. So all those things we have to check. So what you can check is if it is saying if the head is null. So if head equals to null, or k is less than equals to 1, then we have to return null. Yeah, because no relation. Lastly, what you have to do is we have to initialize the variables, right? So what are the variable? Initialize current to the head of the linked list. So what you can say is node current equals to head. What I can write is node current equals to head. Next it is saying set previous to null, node previous equals to null. And lastly what I can do is set the count. So I will take a counter and count equals to 0. Traverse the linked list. So how we are traversing the linked list? Okay, so here variables are initialized, right? So here the variables are initialized. Now when it comes to traversing, traverse the linked list, what I'm going to do is I'm going to run a loop, and the loop will be like current not equals to null. The loop will run till current not becomes null. Next is increment while current not, increment count by 1. So count plus plus is incrementing the count by null. What next? If true, it means the current node should be removed. Okay, so check if count is a multiple of k. Yes, because why multiple of k? Because whenever we are taking, say for example, k is 3, so it is basically the third multiple in a, you have to check the indices, and the third element has to be removed from every position. So it's like a multiple of 3, and it's like following the multiplication order. So like 1 3 6, if it's 3, if it is 2, it is 2 4 6 8, like that. So I'm going to check over here. I'm going to check over here that if count is a multiple of k, so count modulus k equals to 0. To check count is a multiple of k, if true, current node should be removed. Okay, so we will perform the operations. If true, it means the current node should be removed. If previous is not equals to null, so if previous not equals to null, what we can do is we have to update previous next pointer to skip the current node. Okay, so previous dot next equals to previous dot next equals to current dot next. If you want to know what it is doing, you just can simply go, you can simply go to this. I'm going to copy it over here and give the comments. Yeah, so update the previous next pointer to skip the current element. So next condition will be if or not if the previous is null. So this was the if part, right? So we have to also make an else, which means like we have to do null. It means current node is the head. So current head equals to current dot next. So after the if condition is done, the else condition is done, we have to do is we have to take the else of this particular thing. So what we can do is previous equals to current. Why it is so? Because it is saying update previous pointer to the current node. How it is updated? If k is not a multiple of k, so when this is if condition, the if condition is ending over here, and after that, if it is not a multiple of k, say for example, it is not a multiple of k, so the example which clearly denotes not a multiple of k, or elements which don't belong to k series. It's like the ones which are not being skipped. Okay, move, it is saying update previous to current. Okay, previous equals to current. Next, move to the next node by updating current to the current's next. So what basically we can do is, what we can see is in the next condition, we have to update, we have to, in the else part, we have to move to the next node by updating current to the current's next. So clearly you can see that the previous element has been updated, previous to point to the current node is done. Okay, and else part is also done. So we have to now move. So move next node by updating current equals to current dot next. And we have also, we have to also left, we are left with closing the while loop. Yes, while loop has been closed over here, and the head is also returned, head of the modified linked list. So let's execute our program. So no delete, no delete. It is saying class interface or enum expected. Now it should work. Edit of the file while compiling. Let's check. Let's try. Duplicate class node, node.java. So line 64, it is saying duplicate class node. So did they already make? Yeah, they have already made the node class in the driver function. So we will run it. Int cannot be converted to node. Int prev equals to 0. No. Let's compile. So yeah, so if you want to see the code, you can see the code over here. I'm scrolling it so that you can see this code. This is the final code and it is working. Thank you for kindly be patient with today's problem statement. Submit. So we have completed 75 days of challenge, and anything like in life, remember always, whenever you want to do something, do it for 75 days and you will surely see a change in yourself. Thank you.